Greetings everyone. Welcome to this session. We will be looking at wildlife hazards monitoring and also looking at change analysis. So my name is Christopher Mudavi Ameyo. I'm a GIS Seascape Ecosystems expert here at RCMRD. Welcome to the session. So we start by looking at what we mean by wildlife hazards in this context. So hazards are natural or human-driven events that harm wildlife populations. So that is the definition that we are going to adopt for this session. So whatever we will be doing for this session, it will be revolving around what is the possible harm or potential harm that can be caused to wildlife populations. So what are some of these hazards and what do they lead to? So these hazards, some of these hazards include habitat destruction, includes poaching, droughts, that's climate change, and also introduction of invasive species within a protected area. So what are the possible effects of these hazards? So these hazards might lead to extinction risk to wildlife, and also they could cause an imbalance in ecosystems. So how are these hazards classified? So we have anthropogenic. These are hazards that are caused by human actions, and we have natural hazards. So which are the anthropogenic? Anthropogenic may include habitat loss, may include pollution. Habitat loss is because of land use change. It's because of fragmentation, etc. So pollution is also a possible hazard, and it might be air pollution, it could be oil spills in water bodies, thermal pollution in aquatic ecosystems, introduction of chemicals in the soil, including pesticides, etc. And also noise is a pollution that may disturb the wildlife. So climate change is also a possible threat or hazard caused by human activities, and also overexploitation of resources like poaching, overexploitation of timber, overfishing, etc. We also have introduction of invasive species. We've seen invasive species like Opuntia stricta, the Prosopis juliflora, etc., colonizing areas, and they outcompete the native species, making the ecosystem imbalance. So we also have wildlife, natural threats, which include wildfires, floods, hurricanes in some places, and also disease outbreaks. And then predation and competition can also be a risk in that if the protected area is past its carrying capacity, then there is a possibility of maybe a shortage of herbivores in the ecosystems because of maybe predation, etc. And then we also have resource fluctuations, which is also a possible threat. So some of the impacts of these hazards are as outlined in the table. So we have habitat loss. Habitat loss may cause population decline and also genetic isolation, and even may lead to extinction of species. And then chemical pollution. Chemical pollution can lead to maybe mutation within organisms, which may lead to failures in reproductive systems, and they may also lead to mortality of these organisms. And then climate change. Climate change, we have climate change may lead to habitat loss, may lead to species range shifts. And invasive species, we've just talked about invasive species, overexploitation of resources within the protected areas, and also natural disasters. Now, how do we monitor or assess these hazards within the protected areas? So one of the ways of assessing is through field surveys. And field surveys may include use of camera traps, patrols, etc. And then we also have remote sensing. Remote sensing, my colleague Martin introduced us to what remote sensing is and different types of sensors and platforms. So he talked about the use of drones, use of satellites. So in the next exercise, within this session, we will be looking at how to use some of these tools to monitor or maybe assess the impacts of these hazards to the ecosystems or the protected areas. So we can also monitor ecological indicators like pollution within the soil, like water quality. You look at turbidity, pollution in the water bodies, etc. And also look at surveillance of wildlife health. And IUCN Red List also updates the status or the threat status to wildlife. So it is also a possible way of looking at the threats within the protected areas. So when you are doing the assessments or monitoring, you look at things like species. You have to identify the specific species and what are these species vulnerable to. For example, if you are looking at a protected area and it is mainly within the savanna grasslands, so we are talking about maybe the grass. How vulnerable is the grass to maybe effects of climate change like drought, and what are the possible outcomes or consequences of grass maybe drying during drought, etc. And also maybe you can as well look at during forest fires or wildfires, what specific species are most vulnerable. According to my experience, I've experienced some species like Tachonanthus camphoratus, which are more vulnerable to fire. They spread fire at a very high speed. So if you have an ecosystem with such species, it means they are more vulnerable to wildfires. So species identification is key, and also temporal patterns. What has been the occurrences of these threats within the ecosystem or within the protected area? So how frequent has they been? For example, if we have wildfires yearly, then you can plan. You can plan on how to mitigate based on history, what has been happening. That's why the next exercise will be looking at maybe the changes within the land cover changes within the protected areas, and even go further to try and see what could be the possible causes of or drivers to these changes. And then spatial mapping. Spatial mapping include coming up with the risk maps. You can, using factors that cause those risks to the ecosystem, you can model them in a way that they're able to show you which areas are more vulnerable to those risks. And also predictive models. So this comes in form of you can have a system like an early warning system, just to inform what might be coming in future based on what has been happening within the ecosystem over time. So how do we use GIS and remote sensing in hazard mapping? So one, by detecting maybe changes within the land cover changes, you might realize that we are losing habitats, and this is quite important. So coming up with maps that show the trend within the protected areas in terms of habitats. Mapping out pollution, maybe within the aquatic ecosystems, within the air. We are able to identify possible trend or threats to the ecosystem. And projecting climate change, effects of climate change, maybe whether we are going to have a drought, whether there is a likelihood of having El Nino or La Nina or whatever occurrence that might be as a result of climate change. So those predictions or projections are quite important. And then anti-poaching patrol maps. So when you have occurrences of poaching, in the previous exercises you did some good maps on, I've seen people did very good maps on poaching in, was it Zambia or Zimbabwe? I think so. So yeah, coming up with those anti-poaching patrol maps, they're quite important because they're able to show you, or maybe to inform you on where specifically are these poaching activities happening, and then you are able to do to mitigate, to put in mitigation measures to such. So mapping out invasive species spread, coming up with maps of how the invasive species are spreading. You are able to monitor the spreading, the speed, how fast are they spreading, so that you can put in necessary mitigation measures. And then we have disaster vulnerability overlays. So remember we said in the previous slide, we said that you can overlay different data sets that indicates that will indicate to you which areas are more vulnerable to certain disasters or certain risks. So some of the case studies that we will be, the case studies or some of the things that you are able to do in that as listed in that slide over there. So you will go through the slides and see what are you able to do, maybe as an individual or as an institution. So later on we will be looking at some of these cases. So including, for example, we will be looking at, we will do a sample of identifying the effects of fire, wildfire in a a certain protected area. So that's it for the wildlife hazard monitoring. Maybe we will move to change analysis, which is one of the ways of looking at habitat loss, or maybe habitat loss, fragmentation, etc. within a protected. Sorry? Somebody speaking? Yeah, so we will be, maybe we proceed. You can now allow me to proceed to land cover mapping, which is an essential process in terms of identifying trends within habitats, especially in the ecosystems, or maybe in the protected areas. So we will be doing some practicals on this, and I had yesterday you were asked to download some data for this exercise. I hope you've downloaded. Maybe if you've not downloaded, kindly go ahead and start downloading, so that when we start the session, the practical session, you are able to follow. So the data sets were MAU, the under habitat loss, I think, the under wildlife monitoring, wildlife hazard monitoring in your e-learning platform. So you'll see data sets called MAU, MAU AOI, that is area of interest, MAU 1995 and MAU 2025. So download those data sets so that you are able to follow along as we do the practicals. So if you start downloading now, it will be better, because once we are done with this presentation, with these slides, we will go direct to the practical session. So what is land cover mapping, or what is land cover? So there are these two terms. There is land cover and there is land use. And we tend to confuse them a bit. So land cover is exactly what is on the Earth's surface at the moment, or maybe at the time that you are mapping. And land use is what the land is used for. So for example, if you look at the first photo in the slide, so you'll see that is a forest. But within the forest, there is a place that has been deforested. So you may find that place being used for maybe agriculture, but it's still in the forest land. Oh. Sorry, let me reshare. Let me reshare my slides. Being informed that you are not able to see the slides. I hope you are now able to see my slides. Okay. Now, I was defining the two terms, land cover and land use. So land use, we've said it is what that particular area is used for. So, and I've indicated like an example of what we are seeing on the screen. That is our forest land. So the land use could be forest land, but within the forest land, you'll find that there is a forest, and there is also a bare area or a cleared area, which might also be used for other activities. For example, it might be used for agriculture, it might be used for other activities. So those other activities are the land cover. But the general use for that particular area is land use. So now, how do we map a land cover so that we come up with maps like this one? So a land cover is just simply a process of assigning values or land cover classes to pixels. So my colleague introduced images. We talked about raster data and vector data, and we said raster data is represented in terms of pixels, and those pixels are the smaller units of an image. Yeah? So assigning land cover classes or values to those pixels is what we are calling as image classification. And some of the satellite images that we will be using are multispectral images. My colleague also introduced us to different types of images. He talked about hyperspectral images, multispectral images. We also have panchromatic images. So I won't go into details of that. But just to mention that in the exercise that we will be doing after these slides, we will be using multispectral images, and I'll be explaining which bands are we using and why are we using them. So application of classification, I think we've talked a bit about this. Monitoring deforestation activities or trends. You can assess carbon sinks simply means forests are major carbon sinks. So they absorb a lot of carbon dioxide. So you can assess how much carbon is stored in a forest. And then also mapping urban growth, infrastructure. Yeah, you can map so many things. So we will be, during image classification, these are the processes that are followed. One is pre-processing, and pre-processing, some of the images are already downloaded, pre-processed. So now the pre-processing that remains includes maybe layer stacking, maybe mosaicing in case the scene doesn't cover your area of interest, maybe reprojecting if you wish to use a different projection system, or if you wish to harmonize a projection system, especially for images that are within scenes that fall in different zones, for example, UTM zones. Yeah, and then we have training samples. So you now do what we call a collection of training samples or clusters. So clusters is especially for unsupervised classification. And then you apply classification algorithms. We will be looking at different algorithms, and and we will be using some of them today in the next session. So, and then we have post-classification or refinement. So post-classification includes filtering. Filtering helps in reducing misclassifications, and also recording. Recording, especially if you are using unsupervised classification, you might need to merge maybe 2 or 3 different classes together, and that you merge them by recording. So there are 2 different types of classifications. We have unsupervised and supervised. So supervised requires training samples, while unsupervised doesn't require any training samples. So it only looks at similarities, spectral similarities within pixels, and clusters them together. So some of the algorithms used in unsupervised classification includes k-means clustering, isodata, hierarchical clustering. So you'll this PPT has been uploaded. You'll read this, and we are also going to use some of them. So for supervised classification, some of the algorithms includes maximum likelihood, includes support vector machines, and then also random forests. So these algorithms, we will be using some of them, especially the support vector machine and random forest to classify land cover in the next activity. And then we also have deep learning algorithms. So you will also read this. It's uploaded. So that is it for the theory part of it. So you will allow me now to move to practical, hoping that you've downloaded the data already, so we can maybe I give you 3 minutes break, and then we start the practicals. Now, you downloaded this data. We have data for Mau region. So Mau, it's a protected area within Kenya. So we will be using an example of that protected area. I've combined about 3 protected areas within that region in the same boundary, and you will see the reasons as we go along. So, I uploaded data for 2025 and data for 1995. So we want to do some land cover analysis. We see what has been happening within that ecosystem for those years. So if you downloaded that data, then you need to unzip. You need to unzip the folders. So the first one is Landsat 2025. Kindly unzip it. After unzipping it, you will see the folder has several bands. The folder has several bands. So for Landsat, for 2025, it's Landsat 8, and Landsat 8, for Landsat 8, you will be using band 2, 3, 4, 5, 6, and 7. So we won't use band 1 and band 8 because band 1 is for coastal aerosol, band 8 is the panchromatic band. So that's why I didn't include it in your folder. You won't be able to see it. So with that, we need to stack the images together. You were trained yesterday on how to stack the images. So I believe you still remember. Just to mention that for Landsat 8, we will be stacking band 2, 3, 4, 5, 6, and 7. So those are 6 bands. For 1995, we will be using bands list. So for 1995, you have band 1, band 2, 3, 4, 5, and then band 7. I did not include band 6. Why? Because band 6 is thermal infrared band, a thermal band. So a thermal band is used for things like temperatures, etc. So we will not use band 6. So you'll be stacking band 2, 3, 4, 1, 2, 3, 4, 5, and then 7. So having said that, I had already done the stacking, and the stacks were, the composites were uploaded as Mau. Maybe I just confirmed the name, but the composites were uploaded. So if you downloaded the composites, then we can go ahead and start using them right away instead of compositing them again. So there is a folder called MAU area stacked images for land cover analysis. If you downloaded that, then we can use that. If you wish that I go through the stacking again, you'll let me know. So I will go ahead and load the stacks. Maybe I will start with the one for 2025. MAU 2025 stack. The syntax of the name is MAU 2025-0208 stack. So 02 means February, 08 is the day, the specific day. So the image was acquired on 8th February 2025. So this is the area. This is the area that Okay, I will go through the process of stacking the bands. That's fine. So stacking the bands, click on imagery. Okay, first of all, if you opened your ArcGIS Pro, click on project. I want us to do some settings so that your Pro will be displaying just like mine. So click on project there, then click on options. You will have this dialog box. So in this dialog box, scroll to where? Scroll down. Just a minute. Raster, I'm looking for raster and imagery. Scroll down to raster and imagery. And then in the appearance, collapse that arrow. In the appearance, click on appearance. So set it for 3-band data, you can set it to 432. So band 4, band 3, band 2, in that order. That is red is 4, green is 3, blue is 2. And then for 3 multispectral data, use band 4, 3, 2. For 3-band, use 3, 2, 1. So that when you load data, it will be displaying just like mine. And then at custom rendering defaults, check that box to mean that any background value will be, any value that is 0 will be treated as background value. It will be treated as no data, and it will not be displayed. So after setting that, click on OK. And then we proceed to stacking. So stacking, just click on imagery. And then there is raster functions. Click on it. Okay, I will repeat again. So once you open your project, ArcGIS Pro, click on project. Then click on options, and then scroll down to raster and imagery, and then click on appearance. At the appearance, there are 2 options, at the set default RGB composition. So under 3-band data, set red as 3, green as 2, blue as 1. For multispectral data, set red as 4, green as 3, blue as 2. And then check this box. Checking means you tick. You tick this box at the custom rendering defaults. Once you do that, click on OK. Now, after that, we go direct to stacking. So stacking, click on imagery in the tabs. So imagery is a tab. So once you click on imagery tab, you'll be able to see raster functions. Click on it. Once you click on it, it will open raster function tools on the right. So while there, scroll down to management and then click on management. And then you'll see composite bands. Composite bands. Click on it. It will open there. Once it opens, there is this button here. I hope you are able to see my cursor. There is this button here, a plus button that's called browse. So click on it to browse to where your bands are. And navigate to the folder where you saved your data. So we are compositing Landsat 8. So for Landsat 8, we said composite band 2. So select 2, 3, 4, 5, 6, and 7. And then click OK. Once you are there, you can scroll here to see. You need to ensure that the bands are following each other in the order of 2, 3, 4, 5, 6, and 7. If they're not, you click on the one that is not ordered well and use any of these buttons to navigate it to where it should be. So according to this, they are well arranged. So just click on Create New Layer. Yeah, that is my composite. So we've just created a composite. That is what we are calling stacking. So that means we have stacked all those bands together, and that's why we are able to see whatever we are seeing on the screen. So if you right-click in the content pane, if you right-click on the red, you'll see a list of the 6 bands that you stacked together. Remember, we stacked band 2, 3, 4, 5, 6, and 7. Now, at this point, we need to mask to our area of study, area of interest, and the area of interest is the Mau region. So you can load Mau, the AOI, the boundary. It's called Eastern Mau Reserve. The boundary that I uploaded in the e-learning platform, you load it. That is the boundary. So we want to mask or clip to that particular area of interest. So at that point, we will go to Analysis, click on Tools, and then just, overlay. Mine is already there. No, extraction. So you click on, after you click on Tools, it will load the geoprocessing tools in a pane on the right. So while there, click on toolboxes here, and then click on Spatial Analyst. Spatial Analyst is down. You need to scroll. Click on Spatial Analyst. So once you are at Spatial Analyst, click on Extraction. And then there is Extract by Mask. And then select your bands, the composite. And then for input raster or feature mask data. So the mask data is our boundary, the area of interest that you downloaded. And then the output raster, you can click on it and save it in your folder. Because I had stacked, I can create another folder here and call it new stack or stack 2. So inside it, open the folder that you want to save in and give it a name. For example, Mau area stack 2025. It is important to include the year. So 2025 and then .tif. And then click on OK. And then at extraction area, set it to inside. Inside, because we are saying we are masking, we need the data that is inside our mask layer, and our mask layer is the Mau boundary. So, and then run. Click on run. Yeah, it has done it. So we now have our Mau clip here. It's here now. I hope you are having this now. Now we can go ahead and do classification. So remember we said we have two types of classification. We have unsupervised and supervised. So I wish to start with the supervised. We start with supervised. And then if time allows, we will do unsupervised. So supervised classification. So to start the classification, remember the processes that we talked about. We said you start with the pre-processing. So we have already pre-processed. Some of the processes of pre-processing are those that we've just done: clipping, reprojection. Okay, I will repeat. Okay, I will repeat the masking process. So let me remove what we have already masked and retain the composite. So masking, you click on click on analysis and then click on tools, and then at tools there is this toolboxes. So click on toolboxes, and then at toolboxes navigate down. You scroll down up to where you will see spatial analyst. So at spatial analyst, click on the arrow that is just beside it, and then you will see the other categories like conditional, density, distance, etc. So click on extraction. after you've clicked on extraction, you'll see extract by mask. Click on it. Now there is a dialog box in the pane, in the job processing pane, where you need to set the input raster. The input raster is our composite or our stack. So it's the composite bands. And then the input raster of feature mask data is the area, the boundary that you want to use to clip. So it is our boundary, the AOI that you downloaded. So it is MAU AOI. And then output raster, it's where you save your result. So click on that folder. There it will open a dialog box for output raster. Navigate, browse to a folder where you are saving your data, and then give it a name. You can call it MAU area stack 2025. So for me, I can call it 2025. Because I had already stuck, I can call it 2. And then click on OK. And then go back to your job processing pane and click on Run. Yeah, it will take a few minutes and then, yeah, it's done. So it has already clipped. So if you now uncheck in the contents, if you now uncheck the composite bands, you remain with your stack. Yeah, so that is how we do stacking and masking. Masking is also called clipping. So that is how we do it. Now, this is what we will use for land cover classification. I can now remove the composite bands because I don't need it now. For land cover classification, you'll go to imagery, and then land cover classification, we said we have supervised and unsupervised. So in this exercise, we will be doing supervised. Maybe we can do unsupervised later after this. So supervised, we said supervised uses training samples, training labels. So you have to have some knowledge about that area. So because you need to train the model for it to run the classification. So you click on imagery and then click on raster functions. Imagery is a tab. So click on imagery tab, then click on raster functions. It will open the raster functions in a pane on the right. Oh no, we are doing classification, so we don't need raster functions, sorry. Click on the image in the contents. In the contents pane, click on the image. But you must be in the imagery tab. So click on the image, so that is MAU area stack 2025, and then click on classification tools. You can see classification tools here. Click on it. And then we need to do training samples, because we said for supervised classification, you need to train the model for it to run. So we need to do training samples first. After doing the training samples, then we will classify. So click on training samples. It will open a window here. I can close this window so that I remain with the few windows. So it will open a another pane called the image classification. And then it has some default schema for classes. So we will edit these classes to suit the classes that are in our image here. So for us, I would like us to edit these classes. So, or you can as well add new classes if you wish, or maybe edit a schema. You can save your own schema. So what we will do here, these are the classes that are here by default from the National Land Cover Database. So in our classes, we will need water body, we will need forest, we will need forest, we will need maybe grasslands or shrublands, and we will need planted or cultivated areas. So we are going to delete what we don't need and remain with what we need, and also customize it. So for example, I could delete, maybe let's delete the forest. Just right click on it and remove. Then say yes. So we now have fewer classes. So we will need water body. So you can calculate, you can right click on the water body and edit, click on edit properties. So the name is there, the name there is water. We can retain it as a water, or maybe if you wish to call it a wetland, maybe let's just retain water. And the code is 10. We can have it as 10, no problem. You can as well customize the code according to what you want to use. So the color, let's give it blue. Just give it blue and then click on OK. Then the other class will be developed area. Right click on it, edit properties. Let's call it built up area or settlements. Built up, or let's call it settlements. Settlements. The value is 20. We can retain that. Can retain everything else. And then the other one is barren. Barren is bare areas. Let's delete that. Right click on it and remove class. Yes. And then shrublands. Shrublands. Let's retain shrublands. Or maybe let's call it grasslands. Let's have grasslands. Instead of shrubland, call it grassland, and then OK. This is code 10, this 20. The grassland, let it be code 30. You can use 1, 2, 3, whatever you wish to use. And then herbaceous, let's delete that. Herbaceous, we will classify herbaceous together with the grasslands. And then I'm trying to adopt the IPCC classes. So IPCC uses 6 classes and it has the definitions of each class. So cultivated area, we can leave it planted / cultivated. We can leave it that way. And then wetlands, let us delete wetlands because, no, don't delete. Just change it to forest. forest land to forest land. So let's see whether the codes are matching. This should be 10, 20, 30. For planted, let's give it code 40 instead of 80. Alas, 40. If you wish to give some description for it, you can do that. And then this one, 50. So that we have 10, 20, 30, 40, and 50. It's already there. You already have 50. So this could be 60. Do we have 50? Let me just confirm. This is 10, 10. This is 20, 20. Grassland is 50. Oh, okay. This should be 30. And then planted 40. And then forest land 50. 50 and 50. Okay. Yeah, these are now our classes. We will adopt this. If you want to save this as your template so that next time you just, we can save this. So save as, click on this icon here, save as, and then give it a name, maybe protected area or MAU or protected areas. Maybe let me call it PA template classes. Okay, the organization, you can give it your organization. You can give it a description. I won't give it myself. I'll just leave it that way. And then output location, browse to your folder. Browse to the folder where you've been saving your work. Training, data. Maybe I can save it here as template. LC classes. Name your folder and then give it a name. No, the name, we already gave it a name. Just click on the folder and click on OK. So this is, you are just setting the folder where it will be saved, and then click on save. So it is there. So the next time we need it, we will just load it. So now we go ahead and pick the training samples. So for the water body, there is a water body here in the far end of the image. So click on water body, water, and then there is an icon here called a polygon. So click on it so that we select the pixels with the water, and then go to where the water body is and start digitizing. Once you are done, double click. It will draw a shape within that water body. So the shape of the body, the shape of the polygon, it's not a problem. Just draw whatever you can within the water body. And then look at the image classification dialog box. It has water. It has already indicated water, and it says it has one sample for water. So now the next one is settlements. Click on settlements. If you have several water bodies, you could pick a number of them. I don't know whether we can identify another one. That is what I had identified before. So for settlements, there is a town here. There is a town here. So there is a town here. So this is a town. Just draw something there and double click to finish. I'm assuming you still remember how to interpret images. Martin took us through yesterday. So this is a town. So we've already done another sample point for a town. Now we can do another one for grasslands. So within this, this is a grassland. There are so many grasslands within that forest. You can pick one, double click, that's a grassland. And then for planted or cultivated, all these areas are planted areas. So we will have several because we have different shades of planted areas. You can have a few. So you look at distinct colors and then you digitize them. Don't digitize similar colors. Just the same color for so many training sites. Okay, then we do some for forest. Forest, we have several because if you look at this, we are using a false color near infrared composite. And for the false color near infrared composite, deep red represents forests or healthy vegetation. So if you look at this is a forest. If you look at the pattern, it indicates that it's more like a planted forest. And this is a natural forest. Also digitize one there. Look at this one is a forest. And if you look at it, the color is a bit different. This is also a forest. So you can have several. I think I'll use those ones meanwhile. Now, once you've done that, in the image classification pane, down there, you need to edit the classes. So we didn't change the color for forest. Maybe we can make it, right click on it and make it green. I think green is better. Yeah, for forest, yes. So, okay, click on, if you look at the training samples, most of them have 1, 1, 1, 1. But then look at the planted forests, the planted or cultivated areas. We have several training sites. So click on the first one, control and click the others, select all the planted and click this icon here that is called collapse. So it will collapse all those training sites into one, but it's one with 3 samples. And then go to forest land, do the same, select them, and then click on the same icon, collapse. Now we have samples for each class. I would like us to use these samples for now. We will improve the classification later. Now that we have the samples, click on this to save the samples. So click on save. And then navigate to your folder. Navigate to the folder where you've been saving your data. Training data. classification. So mine, I'll save it as 2025 samples, mau underscore, and don't use space, use underscore instead. So mau underscore 2025 samples. And then I will save it there. Now we've just collected training samples. Now we need to go to the next step. So allow me to proceed to the next step, which is now the classification itself. So for classification, click on imagery, and then there is image classification tools. Click on that arrow and select classify. In the classify toolbox, in the classify pane or dialog box, we have classifier, set the classifier. I said we have several classifiers, those are algorithms. And we have random forest, we have support vector machine, we have k nearest neighbor. There are so many. But for this, we can use support vector machine, or if you wish, support vector machine and random forest will give you the best accuracies. So if you want to use random forest, it should be somewhere, it's here. But for now, maybe let us use support vector machine. And then for training samples, select your training, the samples that we just saved. I wish we had loaded them here. Just go to map, add data, or maybe no need of loading, you can navigate to where they are. Just click on this folder here. Click on the folder and navigate to the folder where you've saved them. Classifications. Okay, if you can't see them, you click on this button to refresh the page. Sometimes you need to refresh that page so that the folder, whatever is in the folder, is visible. So click on mouse samples, the samples that you saved. And then for maximum number of samples, you can leave it default. 500. Segmented image. Segmented image, this is where you've done segmentation. Segmentation, we've not handled segmentation. Maybe we will do it after this. So then output classified dataset, click on the folder and go to where you want to save your output, your classification, and then give it a name, maybe mau classified 2025. Ensure you are including the year in the name. So mau classified 2025. And then for a classifier definition file, you can use the same folder. Go to the same folder, classification. Yeah, you can maybe mau classifier 2025. The reason as to why we are saving this, it's because for the dataset, for the output dataset, ensure that you put .tif on the name. Okay, I'll just repeat how to save. Output classified dataset, click on the folder, go to the folder where you want to save, give it a name, for example, MAU, classified 2025 .tif, and then save. For output classifier definition file, go to the folder again, call it MAU classifier 2025 .ecd. So the reason as to why we are saving this classifier is because if you want to run the classification again, you don't need to retrain the model. You can simply use this classifier to run. It knows the training sites. It will just run the algorithm and give you the classification. After you've set all this, then click on Run. Give it a few minutes. Yeah, it has classified already. That is our classification. Unfortunately, we forgot to change the color for forest to green. I've changed it to green. Now you can see our classification. I was looking for the water body to see whether it classified it very well. So if you want to see how it has classified, if you go back to if you click on raster layer up there, here in the tabs, on the raster layer there is a tool there called swipe. So just click on that swipe and start scrolling. You'll see whether, yeah, you can check whether it has classified well. Yeah, yes. I think this is good. For me, this is good. I don't know how yours is, but mine, I'm okay with it. So we've just run a classification successfully. So later on, you see that these small pixels that have been, for example, this one, if you scroll through, you realize that this is not a water body, but it has classified as a water body. Later on, we will see how to eliminate them. That is now post-processing, post-classification, yeah? You remember the flow chart. We started from pre-processing, sample collections, and sample collection, we did the training samples here. And now we've done the classification itself, that is running the algorithm. And now there will be post-processing, which includes filtering, recording, etc. So with this, we would like to do some, once you have a classification like this, yeah, me, I'm happy with mine. Once you have a classification like this, you can now go ahead and do some accuracy assessment just to see whether your classification has captured the classes accurately, or how accurate. You need to quantify how accurate has it captured the classes. I will repeat. Now, we have our stack here, our image stack. It's here. Now we need to do training samples. We need to pick training samples, and then we classify, we run the algorithm. So picking the training samples, you click on imagery here, and then there is a classification tools. Click on the arrow, and then click on training sample manager. It will open here. Once it opens, it is still remembering the classes that we had set. So I will delete this training data that we have. Yes, so that we redo. Now these are our training samples. I hope we are here. Now we have water, we have settlements, we have grasslands, we have planted stroke cultivated, and then we have forest land. So within these samples, if you think there is another class that is represented in the image, but it has not been captured here, you can just click on this and add a new class, this plus button. Or right click on the classes and add new class. So if you think there is a class that is not here, yet it should be there. So you right click, add new class, and set the parameters. If you think there is a class here that is not supposed to be here, you can go ahead and right click on it and remove it. Once you are satisfied that you have the classes that you need, click on the first class, navigate to the image. So I'm zooming in so that you see where the water body is. So in the last segment of the image, so there is this is the water body. Oh, sorry. I will escape. So right click on the water here and then click on the polygon. Click on polygon and then go to the image where the water body is. Just click and start drawing. Start drawing. Once you are done with the drawing, double click to finish. So it has indicated that we have one sample for water. You can draw another one. Let me assume this is a different water body. I draw so that we have two. So if you have another water body in another area, like maybe if we had one here, we would have added another one. Now, we go to settlements. Let's identify where the settlements are in the image. And these settlements are here. Settlements, I mean town, not the small houses. This is our town center. So go there, click on the polygon, and then digitize. The drawing is what I'm referring to digitizing. So if you have another settlement, you can still go to it and digitize it. So myself, I just have that one. I think this is another settlement. But let's use the one that we are sure of, the one that we've already digitized. And then grassland, click on grassland and navigate to, especially this area has some grasslands. This is a grassland. Just digitize. I want us to use fewer. This is also a grassland. I think those ones are enough for me. Then planted area. We go to, this is a planted area, this is a planted area. There are so many. So we can now digitize them. You can digitize several for planted area. Okay, I think those are enough for me. And then forest, click on forest and go back to your image. You know, while scrolling, I'm clicking on the wheel of the mouse, the mouse wheel. You just click on it and move. It will scroll. It will scroll the image. So this is our forest. So I will digitize that. This is another forest, but they don't look similar. in terms of reflectance. This is another forest that looks different in terms of reflectance. So you are digitizing unique reflectance, spectral reflectance. This is another one, I feel it's unique. And then maybe let me finish with this. You don't have to digitize a similar number to, to mine. Just digitize according to what you are able to see. This is also a forest because this is bamboo. In Kenya, bamboo, we classify it as a forest. So once you are done with this, go back to your training samples. We need to merge the training samples to collapse them. So the water, we have two. So click on the first one, and then click on the control, click on the second one, just to select all of them, and then click on this button here called collapse to collapse them. Settlements is one. Grasslands, we have to do the same, collapse. Planted areas, we have several. Select all of them, collapse. Forest land, select all of them, collapse. So you will have your 5 classes. Now with this, click on save. Click on save, or it has saved on the one that I had created. But if you want to save a different one, you click on save as. If you want to save a different copy, you click on save as, go to the folder, give it a name, and then you save it. So for me, I want save as because I have already saved. So now you are done with samples, collection of samples. We proceed to classification. So running the algorithm, so click on, while in the imagery tab, click on classification tools, and then click on classify. In the classify box that comes, set the classifier as support vector machine. And random forest, remember random forest gives a better accuracy also. So you can as well use random forest. So for the training samples, click on the folder, this folder, and navigate to where you saved your samples, select it, and load it. The training samples, the maximum number of samples, leave it default. Output, classified dataset, click on the folder, browse to where you want to save it, give it a name, and give it a name. Mine, let me call it version 2 because I already did one. And then give it a name and ensure that you are finishing with .tif. And then for the classification definition file, ECD, click on the folder again, go to where you want to save, give it a name, and then end with .ecd. .ecd. And then once you are done, the output layer type is a raster. We want to save it as a raster. So you then click on run. And let's give it some time to run. Just a few minutes. It doesn't take long because the area is not that big. Good. That is our classification now. That is our classified image. So we are done with classification. Maybe the next step, we can move to how do we look at the accuracy, how do we assess accuracy of this classified image before we proceed to post-classification. Because post-classification means you are satisfied with the image, you think the accuracy is okay, and now you want to do post-analysis and use it for whatever you want to use it for. So accuracy assessment. Accuracy assessment, you'll need to go to Analysis tab and then click on Tools. Then click on Tools. And then now the toolboxes. I think you are still there because we were there a few minutes ago. And now, still under Spatial Analyst, and now we are not looking at extraction. We scroll down to segmentation and classification. And then there is Create Accuracy Assessment Points. Click on that. So the first step of accuracy assessment is to identify the areas that, the points or samples that you want to use for assessment. So that's why we are creating accuracy assessment points. So the input raster is the classified image. So mine is MAU classified 2025 version 2. And then the output accuracy points, click on the folder and then go to where you have been saving your data. And then give it a name, maybe MAU 2025 accuracy points. MAU 2025 accuracy points. Click on OK. And then target field is classified, leave it that way. Number of random points. So these are the number of samples that you want to assess. So how many do you want to assess? The more samples, the better, because it will give a lot of credibility to your classification. But for this exercise, so that it doesn't take long, because if you have more samples, it will take long to process them. I would like us to use maybe 20 samples. Although 20 is too low, but let's use 20 for now, so that it doesn't take long. And then sampling strategy, we leave it, I will repeat. So let me finish this. Sampling strategy, we leave it at stratified random. Stratified random will ensure that at least all the classes have an equal representation or a fair representation in the sampling points. So once you set that, then you click on Run. So let me go back. Umesema? Oh, no, inabidi tu niende hivi. I thought unaniambia nirudie. Okay. So let me just repeat very fast. So to get the geoprocess, to get the accuracy, to carry out the accuracy assessment, you need to create accuracy assessment points, the points that you'll be using for accuracy assessment, and then click on Tools, go to Spatial Analyst, and then in Spatial Analyst, scroll down to Segmentation and Classification, and then create accuracy assessment points. So once you are there, you'll have a box like this. Select the image, the classified image as your raster, and then select, click on the folder to save the accuracy points, MAU, accuracy points. The accuracy points will be saved there, 2025. I said you don't forget to indicate the year. And then the target field is classified. The samples, let's use 20 for now to save on time, and then run. There is an error here. What is the error? Okay, there is an error. Let me troubleshoot. A bug. No. There is an error here. Perhaps I need to redo. Let me just redo it very fast and see whether the error will more classified accuracy. I don't know why it's something unexpected. Yeah, meanwhile you can, but the questions, okay. No, let me try to troubleshoot in a minute. Yeah, okay. Okay, guys, I'm very sorry for the technical hitch. Unfortunately, mine has not been able to run, but that is the process. And maybe I can I can handle I can try to troubleshoot what is causing that problem. And then we continue with the sessions tomorrow. So maybe I'm requesting that we have another session tomorrow, given that we had anticipated that we will be able to finish today, so that you finalize tomorrow. But it's like we can have another session tomorrow, a similar time, 10 to 12, so that we finalize on all pending issues. And then we also address the issues that you may be having that you would like to be addressed. And then you have next week to finalize all the assignments, everything else up to the last assignment, so that you get the last certificate. So I think that will be okay. I've seen Ibrahim Ambale agrees with me. So maybe we take a few minutes for questions if you have any, and then we continue. We finalize tomorrow with the other session that is pending. So I've seen Ibrahim Ambale. Just go ahead. Ibrahim, you raised your hand first. Go ahead. Oh, sorry, my whatever is mute. Sorry. Go ahead now. It's mute. Okay. Maybe I go to Pascal. Is it Murula? Pascal? Pascal, just unmute yourself and go ahead. Pascal Murula. Okay. Maybe I'll move to Nonde Elvis. Nonde? Okay, Leonard. Leonard. Unmute yourself kindly.
But it's not speaking.
Thank you, thank you, thank you. You are now audible.
Is it okay now?
Yes.
Thank you. First of all, I'd like to congratulate you for the good presentation, especially your idea of coming back to repeat what you have said. That is very good. I think I've seen another of your colleagues do that. That is very important for the presenters. For instance, I did remote sensing more than 20 years ago. I'm actually a retiree and I'm a consultant. So the last time I used remote sensing and the project implementation was 10 years ago. So I think you are doing very well. I have comments to make. I don't have a question.
Okay.
I'm a land ecologist and my knowledge of remote sensing is just intermediate, but I have a few things to point out. In picking training samples, I saw that you are doing a lot of generalizations. I think when you see different variations in signatures, like when you are having the case of the forest, where maybe you have a prior knowledge that this is a plantation forest, it is important to give them different classes instead of putting all of them together. Just like in the case of water, when you see water, an open water, it will give a very good signature for water. But suppose you have water that is polluted or silted, you have water that is fully covered by water hyacinth, the signature will be different. So it is good, even though you may think it is water, it is good to give it a different class when you are doing, when you are picking your training samples. The second one, which is related to that, is on accuracy assessment. Again, I saw that you are doing accuracy assessment just here on the platform, which I tend to differ with. There's no way you can do a supervised classification using an algorithm and use accuracy assessment also using an algorithm. There is no way you can do an accuracy assessment without field data. So I think that one, I don't think that one can go to an algorithm. Then it is important to go to the field. When you do classification using training samples, what you have is actually called a preliminary land cover class classification. That preliminary land cover classification can only be confirmed in the field. It cannot again be confirmed from the source of the computer or the algorithm. Somebody needs to go to the field and actually verify, like in the case of the water or the forest, you need to verify that this is a plantation and not an indigenous forest. Only then you can record that one as a forest. But even at that level, from an application point of view, an indigenous forest and a plantation are not the same. So for practical purposes and for demonstration, I think it is perfect. But for project application, I think participants need to know that it is good to, whenever you see a variation in a training signature, you don't need to mask it as the same class. You need to give it a different class. But you can make notes that you suspect there is just a variation of another class you had actually picked. So those are the comments I wanted to make. Otherwise, I think it's so good. Thank you.
Okay, thank you. Is it Leonard? Yeah.
Yes.
Thank you, Leonard, for the comments. They're well noted. Maybe just I can respond to a few of them just to clarify a few things. Number one, when we are picking training samples, it's just for this training, we decided we do general classes based on the IPCC classification of land use so that we don't take that much time to run. But then you will pick your training sites based on the needs of your study. If your study is comprehensive and you need so many classes, maybe you can go ahead and even identify bamboo within the forest. These are bamboo areas. These are areas with eucalyptus, depending now on the spectral signatures, the difference in the spectral signatures. So that is well noted, and maybe participants needs to just know that the training samples will be based on the needs of your study. If you are doing a comprehensive ecological study where you want to even segregate the habitats or the species, then you need to be keen in differentiating different signatures. And then number two, on the accuracy assessment, Mr. Leonard, that was the first step. Maybe I could just highlight the steps here. The first step was to create points. So these are points, these are like samples that you need to carry out accuracy, because accuracy assessment, you won't go to walk everywhere in the field, you'll need to sample. So we are creating points that are supposed to be verified maybe in the field or using any other means, including someone could be flying a plane over a forest, identifying and mapping different whatever they're observing, etc. So the first step is to create the accuracy assessment points. And then the second step is to populate the ground true data. That is now the data that you will have observed in the field. Now we would populate, maybe we have some ground true data that we would use for this training. If not, there are also other ways of identifying, including using very high resolution images. They can as well give you what is exactly on the ground, and you can use it. So once you identify the ground true data and you populate that into the points, then you are able to run what we call a confusion matrix. So the confusion matrix is what you will now interpret to see how the classes that were classified using this algorithm are agreeing with the classes on the ground based on the data that you collected in the field, or based on data that you collected, whether it is remote sensing. Remember, even drone is remote sensing, and a drone can give you the actual field thing on the ground. Yes.
But just add on that, I think you should consider integrating the use of drones to actually confirm the land cover. But even if you do use drones, which would be a better step ahead of where we are today, if you want to use that land cover for project application, you will still have to go to the field, because even if you confirm that it is a forest, so what? If it is a forest, you want to say something about the forest. You will not just say from the land cover. It requires you to go to the ground and collect other attribute data. So there is no alternative to going to the ground. But you can use something like drone to go to a place which is not accessible.
Yeah.
I think you are together.
Yes, we are together. Yeah. Okay. Yes. Then that's well noted. We move to the next person. Edward, are you ready now to? Edward has gone again. Ibrahim, are you ready now? Just unmute yourself and then go ahead. Ibrahim Ambale. Okay. I think there are no more questions because Ibrahim, I don't know whether he has, he raised, Edward is back. Okay, Edward, go ahead.
Okay, can you hear me, Christopher?
Exactly, I can.
I'm sorry I had a problem with the internet connection,
Yes.
but I wanted to contribute in the issue of accuracy assessment. I had asked a question before.
Okay.
First of all, thank you very much for the elaborate presentation.
Thank you.
I'm really happy because it has enlightened me. I've been struggling with some little knowledge of remote sensing on how to do classification using so many softwares. Now I have gotten skills. Thank you very much for this presentation.
You're welcome.
On issues of accuracy assessment, there are two aspects which I would like to add on what Mr. Leonard had asked before. One can do accuracy assessment on historical data. Historical classification, you cannot go to the field and get what was there. Like here, for the case of Mau, we are talking of Mau 2025 and 1995.
Yeah.
You cannot go to the field and do accuracy assessment for 1995 classification when you are in 2025. So for that case, accuracy assessment on using the software works. Now, my question was, at the point you had selected 20 sample points for accuracy assessment.
Yeah.
Is there any scientific relationship between the area coverage? For example, our area of interest for this case is Mau. We have 2 polygons. Is there a relationship between the minimum number of samples
Mato,
where you selected 20
mko na jibu ya hiyo?
results? Thank you very much.
Mko nayo? Or scientific? Okay, thank you, Edward, for your comments and your input. And now back to your question. As for the number of samples for accuracy assessment, yeah, you've noted that we used 20, and we said it's because it's a training and we don't want it to take long to run. But now when you are doing the actual work, you should not be afraid of taking some time to run. So you need to use enough samples. So I think your question is whether there is a scientific provision for accuracy assessment points, the number of samples versus or against the area, the coverage. So myself, I'm not aware of one, but maybe it's something that we need to, we can go ahead and do some more research on it and see whether someone has ever done some good documentation on the same. But now the more the number of samples, accuracy assessment samples, the better, because if you have many samples and you are maybe, let's say you have 500 samples in an area like that one, and then we say out of the 500 samples, 450 of them were accurately classified. You see, now it gives a lot of credibility to your data. It gives a lot of credibility to your data. But if you have samples like 20, the ones we are doing, 20, and then you tell someone maybe 15 of them were correctly classified, so my accuracies are, you see now, the credibility is a bit down. 20 samples for such an area. So maybe, yeah, we need to have many samples, but as to how many per hectare or per whatever area, I've not been keen to, I've not seen any. Maybe it's something that I'll have a look at, and then in tomorrow's session, if I will have found something, we can discuss. So lastly, let's have Ibrahim. Ibrahim, just unmute. Sitaki kurudishia nani Leonard, wameweka kwa chat, eh? Oh, okay. Sitaki kurudishia huyu Leonard, si ndio? Oh, I have been having a technical nisomee juu sioni.
We do not get responses to queries from the community. How will we be supported after the course webinars?
Okay.
Regarding banks, are they usually 1 to 7 only? And
Okay.
Just clarify
passive. Okay. Okay, Ibrahim, I think your questions have been put in the chat. So now let me respond to them. So the first one, we do not get responses to queries on the community. How will we be supported after the course webinars? So just to note that we receive a lot of requests for support, and they come in different forms. There are those that comes through email. We receive a lot of emails. We even receive some on LinkedIn. Some we receive on even WhatsApp. Those who know you, they sent you via WhatsApp, and some are in the community. So we are trying our best to ensure that we are addressing all the issues raised. And the community is actually a better platform because, once an issue is addressed, you are able to follow the string and know how it was responded to. So kindly bear with us. We are still working on it. We are working on the issues. As for post training, the community is still open. We will still continue addressing the issues. So don't worry. The second issue was regarding bands. Are they usually 1 to 7 always? No. Now this depends on the satellites. For example, we are using Landsat. For 2025, we've been using Landsat 8. So for Landsat 8 and Landsat 9, we use bands 2, 3, 4, 5, 6, and 7. We don't use band 1. Why? Because you need to understand what the bands represents. So for Landsat 8, band 1 is coastal aerosol. So the bands that we use, band 2 is blue, band 3 is green, band 4 is red, band 5 is near infrared, and then band 6 and 7 are shortwave infrared. So those are the bands that we use. So whenever you are looking at a satellite, remember that the bands that we are interested in are the bands within the visible light. So that is the RGB, the red, blue, and green, and then near infrared and the shortwave infrared, if they're there. We will be using Sentinel for another exercise if time allows. So Sentinel-2, the bands are different. So for Sentinel-2, we use band 2, 3, 4, band 2, 3, 4, and band 8. Because band 8 is the near infrared, band 2 is blue, band 3 green, 4 is red. So those are 4 bands for Sentinel, because those are the bands with the 10-meter resolution. So when you are talking about Landsat 5, for example, Landsat 5, Landsat 7, the bands that we use are bands 1, 2, 3, 4, 5, and then 7. We don't use band 6. Why? Because band 6 is the thermal band. So we are only interested in the near infrared, shortwave infrared, and then the red, blue, and green. So different sensors have different bands. So even in the Landsat, because we are using the 6 bands, it doesn't mean that it doesn't have other bands. Landsat 8 has almost, I think it's about 12 bands. So the other bands represents different things. There are those bands that will give you information on cloud cover, cloud. There are those bands that will give you information on the thermal bands. Yes, so it depends. Then just clarify what passive remote sensing is. So passive remote sensing, so this is a type of remote sensing that involves sensors that doesn't emit their own light. They don't emit their own light. They depend on maybe sun. For example, right now we are using our phones to take photos, and our phones have inbuilt, is it called a flash? That light that it emits before it captures. So it's a flashlight. So initially, before we had phones that didn't have those flashlights, even cameras, they didn't have those flashlights. So when you take a photo, you must have an external source of light. So for example, if there is, if during the day you can easily take a photo, but at night you need an external source of light. So those sensors that needs an external source of light are the ones that we refer to as passive sensors. And that type of remote sensing is what we refer to passive remote sensing. I hope I've addressed that, because I want us to end it there. I'm not sure whether Leonard was raising a hand again, or he had already spoken. Okay, it's addressed. So allow me to end there so that we meet tomorrow. We finish the land cover analysis, and then we look at another exercise, and then we call it as a training. So we will still support you. You still have next week to finalize all the assignments so that you are able to get the certificates. Otherwise, after next week, you might not be able to access the license. So just ensure that you complete your assignments on time. And then, but the course materials will still be available to you. Thank you and goodbye. Let's meet tomorrow.